last time, let me put our data up here. Unfortunately, I don't want to add you to the data because we already have kind of an established, ooh, who's got the Venn diagram from last time? I have my sample one. Can I borrow?
It's very messy, but you can try.
It's okay, I'll discern it. I think, whoa, okay. It's good, I got it. Here's what we had last time. We ended up with 1, 8, 1, 1. And our Venn diagram looked like this. And I think you guys understand how Venn diagrams work, right? So shared, 8, 1, 1, 1. Okay, this was tongue. And this was eyebrow. What we did was we worked on the skill of taking a chart and making a Venn diagram out of it. When we look at our chart, where did this upper left-hand one go? Do you remember? Somebody who was here, where does the upper left value go? It goes in the middle. So the way that we have to construct our two-way table is the affirmative, so the event goes here and the event goes here. Meaning what I'm actually trying to measure. So can you do taco tongue? Can you do evil eyebrow? Those always go in the upper left part. The complement to those events, so meaning the opposite of what it is, goes in the other one. Yes, evil eyebrow. The complement to that is no evil eyebrow. Yes, taco tongue. The complement to that is no taco tongue. As we fill in our two-way table, it's going to inform our Venn diagram. So the one here, I'll just label this. Let's make this A. Here's A. Then the Pacmen come from the complementary events. Because the complementary events say, I can do this, but not the other. This number 8 says, I can do the taco tongue, but not the evil eyebrow. So I can do the taco tongue, but I'm not in that middle part because I can't do the evil eyebrow. So let's make that B. B. C would be, yes, I can do the evil eyebrow, but no, I can't do the taco tongue. So that's this Pacman. Yes, I can do the evil eyebrow. No, I can't do the taco tongue. The inability to do both is on the outside. What are we doing today? We're going to figure out what things are dependent on one another. So, what I would like for you to work on right now in your groups is the first 1, 2, 3, 4. This first page of day 2. You have some data there. We filled in our chart, so those of our friends that weren't here now have the data from the chart. I want you to work together. You're going to be finding some conditional probabilities. What's the probability of this given that a certain event? My encouragement to you on any two-way table, as I said last time, would be to fill in these numbers. 9, 2, 9, 2. Our totals were 11. Go ahead and work on numbers 1, 3, and 4 together in your groups. Let's talk about this. Suppose we randomly chose a student from class. This is an important piece of the puzzle. The data that we're operating from is just the data from the chart. Just the data from this Venn diagram, okay? It's just from this class. So the only people that can possibly be picked are from this class. So knowing that, what this means is find the probability of yes to taco tongue or yes to evil eyebrow. As we discussed before, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, or A intersect B, meaning what is shared. The rationale behind that would be the probability of someone being in this circle or this circle is this circle plus this circle minus what's shared, because you can't count that person twice. In this case, it would be 9 out of 11 plus 2 out of 11. So let's say you forgot about the shared part. Look at the Venn diagram. is the probability of a person being able to do this or this everybody 100%? No. Why not?
It's one or the other.
There is one person that can't do either of those. So at the very least, you should go back and check your answer and look and say, oh yeah, no, it's not everybody. So we subtract what's shared, and it's equal to 10 out of 11.
What's the difference in where you have like the N thing between the A and the B? What's the difference in that and like the U one?
U is or. So this would actually be,
And they're both adding. It's 20 degrees.
okay, A or B. They're not the same.
Okay.
One means and, the other means or. So
But
intersect.
don't they both mean like adding?
The intersect means shared, so it's both. Union means or. It's like this and this separately added together. Shared. When we go down here, given that a person is selected as yes, evil eyebrow, what is the probability that they are yes, taco tongue? What is the denominator of our fraction here?
Yes, evil eyebrows.
So what's the denominator? What denominator did you put on the fraction?
2.
Why 2?
Because there's only 2 evil eyebrows.
There's only 2 people evil eyebrowed, right? So my denominator is 2. So what's the probability that they are yes to a taco tongue?
1 over 2.
1 out of 2. We need to express this as a decimal and percent. 0.5 equals 50%. It's not a big deal for a half. It's more significant to give it as a percent. Given that the person selected is a no evil eyebrow, what is the probability that they are a yes taco tongue? What's our denominator here? 9. I mean, yes. German lesson. What goes on top? Yes, taco tongue. No evil eyebrow. Express it as a decimal and as a fraction. What did you get?
88.8%.
88.8. So
Oh, 88.9%.
Do you put decimals now or no?
you should put the decimal and you should put the percent.
The percent with the decimal, I mean.
Mhm.
Okay.
Right here. These 2 pieces here. Because we changed the denominator, these are called conditional probability. There's actually a notation for this when we write it out. I'm going to show you what that is. This is how we would write this particular phrase. This is the notation. P, yes, taco tongue, bar, evil eyebrow. This means, literally, given that the person selected is yes, evil eyebrow. So this would be probability that a person is yes, evil eyebrow, given that yes, taco tongue. That's how you read that phrase. Try to write it for this one in probability notation. Write it for the second one. hiding it from me. Here's what I got. The given that goes after the bar. So given that the person is no evil eyebrow, what's the probability of yes taco tongue? After the bar goes the given that.
Wait, so the probability of the person is yes, you are given that yes, taco tongue? Isn't the given that it's evil eyebrow?
Sorry, I wrote that backwards. Taco tongue. Switch this. I'm sorry. Down at the bottom, it gives the definition of two independent. So of independent events. Two events are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. Are the events yes taco tongue and yes evil eyebrow independent? Explain. What do you think?
Yes.
Are they independent?
Yes.
What's your rationale? Why do you think that?
The ability to do taco tongue does not affect the ability to do evil eyebrow.
It's no correlation between the two.
You sure?
Yeah,
You're right.
without an experience.
You're right, yeah. So knowing whether or not a student is yes or no evil eyebrow, it changes the probability they are yes taco tongue. So let me scroll up here. Two events are independent if knowing whether or not one event has occurred does not change the ability of the other event to occur. Are they independent? Talk about it in your groups based on the definition. And look at, does it change if you know one or the other? In number 3, probability yes taco tongue, no evil eyebrow.
Wait.
And then
Yes, evil.
probability of yes evil eyebrow, sorry. Yes taco tongue,
No, you won't.
no evil eyebrow. What was the probability in number 3?
50%.
What was the probability in number 4?
88.9.
Are yes taco tongue and yes evil eyebrow independent? Does knowing one change the probability of the other?
Maybe,
How would you determine that?
is this significant enough?
Is it different?
Yes.
Then no. No. They're not independent. They change. The probability changes.
But what if they change because of like coincidence?
What's that?
What if the reason they changed it because of coincidence? Because we only saw real.
Yes. That's the question that we're answering, though, right? That's the question that we're answering. Is it significant? Well, at the very least, right now, we see that it changes. So, knowing whether or not a student is yes or no evil eyebrow changes the probability So these are not independent events because the denominator changed. Okay, the denominator changed based on what we were measuring. So when we look at these two events together, yes, taco tongue, yes, evil eyebrow, to say that they're independent would mean that knowing one did not change the other. So what we do is we evaluate what is the fraction when it's yes, what is the fraction when it's no. What is the fraction when it's yes? What is the fraction when it's no? And so if they're independent, it shouldn't change. Because independent one wouldn't be dependent on the other. But because it changes, that means they're dependent on one another. Go ahead and flip the page. So for number 6, you're gonna use some data put in here. It's the same kind of a setup, except it's a larger data set. Would like for you to look through number 6 and number 7. Number 6 and number 7. Well, just work on number 6 to begin with. Work on number 6, and then we're going to talk about number 7. So let's just talk for a minute here. That explanation, how many of you were left a little bit wanting after that explanation of events? Oh, yeah.
I just want to see what a yes looks like.
I'm going to show you right now. We're going to do this one first. Let's look at the data here from the table. Hopefully you were able to fill in A, B, and C with very little problem. Maybe D. But let's look at what this means as far as the probability when we look at it from a table. So we've got all this information here. What is the probability of yes taco tongue?
480 over 600.
Yes taco tongue, 480 out of a total of 600.
Yeah.
Other forms,
0.8.
0.8, 80%. Of all the people at this high school, 480 out of the 600 of them can do taco tongue. Think about it like this for a second. If it's independent, meaning it does not depend on whether you can do evil eyebrow or they have nothing to do with one another. If I walk up to a student and they can do evil eyebrow, what percent of people, no matter how many I ask, should be able to do this? 80. It should remain 80. If 80% of people can do this skill, and it's independent, 80% should be reflected no matter what criteria we put on it. In this case, evil eyebrow. So evil eyebrow, if they aren't dependent, if they're independent of one another, the percentage should be the same whether a person can do evil eyebrow or not.
Wait, but if you go ask one person, he says yes, that's
Yeah, but it's
Yes, yes,
so there's no
yes.
causation
So that's what we're trying. So we're getting down the road of determining that. This is our first measuring tool. Out of 600 people, 480 of them can do evil eyebrow. If they're independent, the proportion should be the same for a criteria that isn't related. If it's an independent criteria, it should remain 80%. So now, what's the probability of yes taco tongue given that evil eyebrow? So here's our evil eyebrow. So denominator is 200. What percentage, or what's our numerator? 180 out of 200, which gives us what percent?
80%.
So there is a higher percent of people who can do taco tongue, given that they can do the evil eyebrow, than the population as a whole. You see why this might be alarming? And then when we look at this next statistic, what's our next statistic? No evil eyebrow would be out of 400. How many people out of 400 could do taco tongue, given that no evil eyebrow? 300. So that's 0.75, 75%. Are you starting to walk that road with me? Are you starting to understand what I'm looking at here? when we talk about independence. If it's true that they're independent, they do not depend on one another. If I get a decent sample size, overall 80% can do it. So if I take a large enough sample size, if they're truly independent, it shouldn't matter. It should still be 80%. I asked 600, but I go over here, I take a subsample of these 200. 80% of them should be able to do it. So the question is, well, 90 is pretty close, right? 75 is close. Like, is that close enough? That's what we're going to go down that road of asking. But for our explanation for right now, would we say that these events are independent? No.
He said dependent.
Are they independent? Are these events independent? No. These are actually dependent events. They're not asking you to say, well, what is causing their dependence? Is it genetic? Is it a muscle thing? They're not asking you that. What they're saying is, look at it strictly statistically. Apparently, 80% of people at the school can do this. So if I take a huge group, and the percent is different than the 80, they must depend on one another.
So they can be like dependent, but like say for example, if they were to ask you the reason why, like you'd say coincidence, right? Or
I don't think they're not going to ask you why at this point.
yeah, but like
That's the.
someone's ability to do evil eyebrows and talk like talk.
But so that would cause us to think there's some connection.
Yeah, well,
So what we'd say is we have reason to suspect that these events are not independent. We don't know what it is.
like what happens if they're actually like one doesn't cause the other and it's just coincidence that they happen.
That's what we're going to try to determine. So that's what scientists do. So they see things like this and they go, I wonder if it's because the mom and the dad could do one or the other. I wonder if it's genetics. I wonder if it's something they ate as a baby. Okay, that's kind of where scientists fill it in. But as a statistician, what we're looking at is there a significant difference? And what we're saying right now is, because these don't match the percentage of the overall total, they must be dependent. What is it dependent on? I don't know, but I'm telling you, the statistics are telling me that it's dependent. I know that's not a satisfying answer. I'm sorry. So let's fill in the chart as if they were independent. Well, what does that mean? You tell me. If these are independent, what is it going to look like? What's it going to look like?
They're independent.
What should be true if they're independent?
Equal.
Equal how?
Proportionally.
Say it again.
Proportionally.
Proportionally equal. Yes, they are going to be proportionally equal. So please fill out the chart to make it proportionally equal, whether you have yes, evil eyebrow or no evil eyebrow.
To make it 80%.
That's correct. Yes.
Oh yeah. Yeah.
Are you confused yet?
Yes.
Wait, I'm getting there, I think.
Yes.
I just kept guessing until I got to 80%.
So I just did the total times 0.8.
I'm not going to say anything yet because people are still kind of working. May help to.
Oh, yeah, we did.
Are we supposed to?
So let's look. So how would we calculate this? I think you can guess and check, but once you see kind of how the pieces fit together and where the denominators come from, it's going to be helpful. At the very least, this is what you need to understand. If the events were independent, yes, taco tongue versus evil eyebrow, 480 out of 600, 0.8, 80%. 80% should be the proportion whether you can do evil eyebrow or not. What we are considering here can be summarized by this down at the bottom. So let's do this for just a second. So the proportion, the probability of yes taco tongue is 480 out of 600. What should be true in B and C if they're independent? The answer should be equal to 80% when we get done. And as we work backwards, what is the denominator of our fraction in B?
200.
Yes, evil eyebrow. Well, where do I get that information? The total number of people who could do yes, evil eyebrow is 200. So the bottom of our fraction here is 200. What is 80% of 200? This would be 160. Well, where does that go? If we're filling in the table as if the events are independent, yes to Taco Tongue, yes to Evil Eyebrow would be yes, Taco Tongue, given that Evil Eyebrow, that 160 goes right here. Because I am finding 80% that could do Taco Tongue, regardless of Evil Eyebrow or not. So let's find this box here without going to part C. So if they did no Evil Eyebrow, and I want 80% of people who did no Evil Eyebrow, where do I get my denominator? How many people were no Evil Eyebrow? 400. So down here goes 400, and I want 80% of 400. This would be 320. So this is 80% of 320. This is 80% of 200. That's where I got those numbers.
Is 320 of 400?
Yeah.
Miscopied it off my notes. I made a mistake one time. Today was that day. Just kidding. Joke. It's just so stiff. So stiff. So where do I fill? How do I get the other pieces of the chart?
Subtract it.
You can subtract. So you could calculate 20% or you could subtract. 40 goes here and 80 goes here. Check your total. So 40 plus 80 is not a coincidence. 160 plus 320 is not a coincidence. If they are truly independent, the big proportion matches the proportion of the smaller groups where it's true or not true, meaning yes, Evil Eyebrow, no Evil Eyebrow. So in number 9, what do you notice about your answers in number 6 and 8?
One was independent, one wasn't.
They were. Talk to me about the proportions or the percents.
The percentages of 8 all matched each other, but not in 6.
Yes, all 3 different in 6, all 3 same in 8. Here we go. Let's go in general here. Let's generalize. Complete the following statement using a formula. Let A equal yes Taco Tongue and B is yes Evil Eyebrow. Last time we talked about how to write probability statements using A and B. On the AP exam, when you're doing probability, you can write something like this. On a problem as an answer, but you have to tell them what A and B are. Does that make sense? So I would have to establish A is this event, B is that's what they did here. They said A is Taco Tongue, B is Evil Eyebrow. If A and B are independent, then the probability of A is equal to what?
Probably A. Probably A. Or the line B.
Yeah. If they're independent, then the probability of A happening in the big group is the probability of A happening given that you now have taken a smaller group. You tracking with me? Look at B, look at A. So probability, you're literally, this is substitution, this is algebra, right? A is yes Taco Tongue. So the probability of A, meaning yes Taco Tongue, is the probability of A given that B is equal to, and this one's a little bit trickier, the probability of A given that
B, C.
B complement. Good. And this is a C up here. It's the complement of B. In this case, A given that yes Evil Eyebrow, the temptation here might be to say not B, but the way that we say not B in probability is to say B complement.
How would that be the same? Like, how is that equal? It's it's like the opposite of B has it equal to the same.
Crazy, right? That's what makes them independent.
Yeah,
Because
but
I take this huge group of students, and 80% of them fit into this category.
But 480 are yes, and then 120 are the complement. So
Aha!
I get the
It's the
number.
proportion.
The A is the same number. Like you're dividing by
Mhm.
No, it's not the same number, it's a condition.
It's because of this. You are right. A is the same number, but because you put a condition on it. This line B means given that something else is true. So what we did was, that's where we slice and dice the number in the chart. So A, what's that?
I got all, like I don't understand how you're getting the numbers from the chart either.
Okay,
I always
let's go back. Let's go back. No, this is important. This is foundational.
I got all of them.
This is good. Let me draw a chart
It's just the
over here. I've got this chart. Yes, evil eyebrow. No evil eyebrow. Yes, taco tongue. No taco tongue. 200, 400, 480, 120. These are the actual totals. So 600 students, and 200 of them could do evil eyebrow. 400 of them could not do evil eyebrow. 480 of them could do taco tongue. 120 of them could not do taco tongue. But the ratios could change. There's a lot of things. So like if I put 100 here, then 380 would have to go here, and 300 would have to go here. I could put anything in there. When we do a survey, not just anything goes in there, the actual results go in. But we're saying, in theory, so track with me here. In theory, if the events are truly independent, what we're saying is, these 480 students that could do the taco tongue out of the 600, so 80% could do the taco tongue, then no matter how, so if these two events that I'm choosing to put next to one another, it's not age, it's not gender, it's not grade level, it's just these two. If they're truly independent, when I cut the group down based on some criteria, in this case, can you do evil eyebrow or not? The proportion should stay the same. So when I take a random sample of 200 students, they just happen to do this yes evil eyebrow. If it's not dependent, you should get 80% of them that can do taco tongue. So what we did to calculate the numbers in the chart was we said, right here goes 160, because that's 80% of the total number of people who could do evil eyebrow. Here, 400 people couldn't do it, but 80% of them, if they're independent, 80% of them should fall into that category. So then the others would just be additions and subtractions. So what we're saying down here is the probability of A, meaning 480 out of 600, the probability of taco tongue given that you're a student, is equal to the probability of yes taco tongue. So it's 480 over 600 for this first one. Then it's 160 over 200 for the second one. Then it's 320 over 400 for the third one. P A. P A given that B. P A given that B complement. All right, flip it over. I would like for you to work on the check your understanding in your groups. So let's apply what we just did. So work on the check your understanding, then we're going to hit the notes here in just a minute.
On the test, how would we know that they didn't want you to include renters?
Because it very clearly says owners. So
What,
says
But if
But
you're
say
renting,
you're
you
not
don't
a
own it.
snowmobile owner. You don't own it if you're renting.
That's what's
Yeah, that's what I
confusing
thought
me.
too.
Right. That's correct.
So they don't know.
So it does include renters?
Yes.
Said whoever's.
What?
Wait.
I asked earlier and you said it didn't include renters.
Owners does not include renters.
The one that
So
says
this
not
question
owned.
we do use renters.
Oh, sorry, I misunderstood your question. Yes.
Okay.
You should include renters in that particular question, but I thought you were asking if they're considering a person an owner, would that include renter because they're in charge of it? No. Being in charge of it does not make you an owner. I'm sorry, that's my mistake. Misunderstood the question. When we look at this chart, supposedly we randomly select one of the survey respondents, define events E, environmental club member, S, snowmobile owner, and N, never used. This actually really helps us because imagine what this question, the wording of it would be like if we had to write this all the way out. So that notation really actually helps us. So find P given, the probability of N given that E. Interpret this value in context. What does it mean? Let's find it first. Probability of N given that E. What does it mean?
Given that a person is in environmental club,
Yes? The probability that what?
They
Yeah.
never used-
fine, sorry, I
So
didn't
this is
I didn't answer.
that they've never used a snowmobile.
A person has never used a snowmobile. Given that what?
They're in the club.
They are in what club?
Environmental club.
In the environmental club. This is kind of a distracting example when you write it out. What does it matter if a person's in an environmental club and snowmobiles? But people measure these things. They do this. They measure them. What is the probability of N given that E?
212.
212 out of how many?
305.
You guys agree with this?
Yeah, that's what
Sorry?
was it right?
Do you agree?
Wait,
I mean,
I
I'm
put
fine
that,
with
but
all
now
of
that
them.
I look at it, I'm trying to decide if because I didn't include.
Yeah, so it still wasn't
Yeah, why
right.
wouldn't it be right?
No, that's
Given that they're in
That's
the
right.
so
Do you
all,
have to
these are all the
include
people in the
renters
environmental
this as
club.
well?
So the probability that they've never used, given that
Okay.
they're in the environmental club. That's right.
Why do you
Okay,
make
thank
it
God.
confusing?
That's right.
Now the whole renter thing.
Because this is what happens on the
Yeah.
test, right? You write something you're like, oh, that's right. Be strong. Be courageous. Given that the chosen person is not a snowmobile owner. This is where we got the confusion. I'm sorry about that. What two categories go into not snowmobile owner? Never used or oh, dang it. Could they own one and have never used it? Possible. I think what they mean is this. Given that the person is not a snowmobile owner, so where do I get the two totals that are going to go on the bottom for this, the given that's?
Subtract them from
You can
1,229.
do a complementary of S.
So you could do the complementary of S, or at the very least, your bottom should be 657 plus 574. The total sum of people who fit into these two categories is these two.
It's not 1,000. Oh wait, that's.
Ah, see? So the other way you can do it is to say, here's my total. Here's the person that doesn't fit, the people that don't fit. So 1526 minus 295, or these two added together. Either way you think about it is okay. My denominator is 1231. What is my numerator? What is the probability that he or she is an environmental club member?
12 plus 77.
Yes. So in this case, 212 plus 77. They fit into these categories but also this category. So 212 plus 77, 212 plus 77. My probability would be 289 over 1231, which is 0.235, 23.5%. At the bottom, can someone explain to me what this question is asking? What is it asking you to evaluate here? This is the tricky part. Who's going to go for the gold? You want to go for it?
I don't know why, but I don't think they are.
Are the event snowmobile owner and environmental club member independent?
No.
What does it mean? So you can't just, so no more can you do this, because now you know. You can no longer think, well, yeah, those probably don't have anything to do with one another. Now you know that statistical evidence must be present. On the AP exam, you can't just say, no, because it seems like it. Like, logically, they don't have anything to do with one another. You have to say statistically why. It should look like this. Everyone who owns a snowmobile. So the probability of everyone, if we put it in the context of the previous problem, 80% of people own a snowmobile. That's not true, but let's just say. So if being in the club or not is independent, then if you take a big group of them that just so happen to be in the club, 80% of those should be snowmobile owners. And then you take this other big group that aren't in the club, 80% of them should be should own a snowmobile. Because if the events are independent, then the overall percentage should be reflected in the two groups, because it doesn't matter whether you're in or not. So we're going to evaluate the probability of having a snowmobile versus the probability of having a snowmobile and what?
Given that you're in the environmental club.
Given that you're in the club, and also the probability that you have a snowmobile, I almost put mobile, and what? Not in the club. If they don't have anything to do with one another, then a big group of people who are in and a big group of people who aren't in should have the same percentage, not the same amount, the same percentage of people. Up here, this is 295 out of 1526, which is 19%, 19.3%. If they are truly independent and they don't have anything to do with one another, then 19.3% of people who are in the club and 19.3% of people who aren't in the club should own snowmobiles. But here, it's 16 out of 305. So this is 0.05%. So only 5% of people who are in the club own snowmobiles. Whereas 279 out of 1221.
Where did the 305 come from?
The 305 is the number of people who are in the club. So if you look up at the chart, given that, yes, they're in the club, the denominator would be 305. Not in the club would be everybody else. So that's from the no column. And then we evaluate snowmobile owner versus not. So what say you? Are they independent? No, they're not. You can think that they are, because what does the snowmobile have to do with the environmental club? The statistics say no, not independent. Here's what you're going to try. Numbers. 61, 63, 65, 67, 69, 71, 77, And 79. Yes, that is your homework.